Hey everyone, in this video I will be discussing about recursion in C++. Okay, so let's get started. So this is the definition of recursion. What it is? A process in which a function calls itself directly or indirectly. So the main point of a recursion is this: when a function call itself. So how a function is calling itself, so we will see in this lecture. And you have to do small thing. First is that you have to solve a problem, and you have to just break the big problem into very small problem. And how you can do all those steps I will be discussing in this lecture. So these can be examples. You just go through it, Russian doll, and directly structure of your computer, like folders within a folder. So let's make a code snippet for that. Include IO stream for writing in C++. So basically, what is a recursion? So if a function, let's make a function like void func. If the function is calling itself in the function, so that's how a recursion is being used. So this, if you invoke this function, so this function will start executing, and in line number 4 this function will also executing. So this is how recursion is defined. So let's solve some problem so that you can solve any kind of problem which can be asked in your interviews. So let's get started. So before solving recursion, you have to do something. First you have to understand the base case. What is base case? What is recursion case? So basically you have to find some base case. What is base case? A condition under which the recursion ends. Okay, so there is a condition in your code. So why we need this case? To prevent infinite recursion, because in recursion takes a lot of memory as compared to the iterative method. You can solve the same problem using iteration as well as recursion. So recursion takes more memory as compared to the iteration method, but it is quite simple to understand, so that's why we are using this recursion concepts. So this is, you have to first make a base case. How you can make, I will teach in this lecture. Okay, then a recursive case. So this is the small part of the function that you have to solve. So let's say you have a big problem. Let's say you have a big problem. So if you have a big problem, this kind of problem, let's say this is a big problem, you have to just solve the smallest part of this problem, just repeating the same things so that you can solve the big problem also. So that's how you have to just do one thing, that you have to solve a smallest part of the function and just repeat the same process, so that, or just calling the function so that you can solve a big problem. So this is the example of factorial. So before understanding this code, I have to explain it to you. What is a factorial? So let's say int n and c in n, I'm taking from user, and I'm creating a function for factorial. And before creating a function in factorial, I have to explain what is a factorial. So basically, what is factorial? So if someone will ask you what is the factorial of n, so n should be equals to n into n minus 1 into n minus 2 into up to 3 multiplied by 2 multiplied by 1. So that's how a factorial is defined. For example, let's say for 5 factorial, so what it is? 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So that's how a factorial is defined. So this is factorial. You have to start from that number and ends with 1, and just multiplying all its consecutive lesser number. Okay, so that's how a factorial is defined. So I'm able to explain to you what is the meaning of factorial. You can play with another test case. So let's make a function. I'm creating a void function for that, and I'm passing an integer variable, so that's why I'm creating int n. So to solve a problem in recursion, you have to just do one thing, is that you have to just create a base case. Base case is simply means the smallest problem, the smallest. What it is, for solving a problem on factorial, we always know that 0 factorial is equal to 1, as well as 1 factorial is also equal to 1. So this is the base case, because this is the smallest sub problem that you have to solve so that you can solve the problem of factorial. So I have to do something, is that if n that you have given in the input, if it is equal to 0, or is it equal to 1, then you have to just return, or just say return 1. For that reason, you have to make this void function to int function. So that's how the whole code will be working. I have explained in functions lecture that how int function you have to return something, and for non-void function you don't have to return anything. So now you have solved the sub problem of this problem, and then you have to just solve for a generic case. So just you have to what, you have to store a, then you have to just call this function by, because in any problem of recursion you have to call the function itself. So you have solved for a case, then you have to just do it. It's like that. Let's say the answer should be equals to n multiplied by factorial of just n minus 1. I will explain this all again. So that's how, and just return the answer. I will write on each and every part so that everyone can understand why I'm doing all those stuffs. And let's see that it is working or not. Then just see out all those stuffs. So let's execute this code, and let's say I'm printing for, let's say 3, then answer should be what, 1 multiplied by 2 multiplied by 3, which is equal to 6. So is it printing? Yes, it is printing. And as we all know that for factorial is equal to 4, which is equal to 24, which is quite correct. So that's how the whole code is perfectly fine. So let's explain each and every part what I have done on this code. Okay, so first thing, I have created a int variable, and just I'm taking input from user. So that's how you also understand what it is. It is very simple. And just I'm printing the value of factorial. Okay, so I'm making a function called factorial. I'm passing it n as a int n as a variable. I've created a base case. Base case, what it is the smallest case. Why we are using base case? Because to avoid the stack overflow condition. So that's how we are using this thing. So in base case, always you have to remember, you have to solve the smallest part of the problem. You have to solve the smallest sub problem so that you can basically prevent from infinite recursion. Got it? Then you have to solve for a generic case. For a generic case, what it is, you have to just solve for n multiplied by this factorial n minus 1. So in this answer variable, what it is storing, n, let's say the n is equal to, let's say 5. Okay, so the 5 will be given here. First, how the code is working, so you are giving, let's say n is equal to, let's say 5. Okay, so checking here, is it n is equal to 5? No, it is not. So it will be not going in this case. Okay, so in another case, in the line number 8, answer variable is storing is 5 multiplied by factorial of 5 minus 1, which is equal to 4. So after that, the same function is calling. So then after they are checking that is 4 is equal to 0 or 1. No, it is not. So then again this function is calling, like n here is 4 multiplied by factorial 4 minus 1, which is equal to 3. After that, the same function is calling itself. So how it is? So now it is 3. So is 3 is equal to 0 or 1? No, it is not. So then again this function will be called, which is 3 into factorial 3 minus 1, which is equal to 2. And again this is called. So here int n, which is you have given that 2, then is 2 is equal to 0 or 1? No, it is not. And again this is called, and n multiplied by, which is 2 multiplied by what, 1, then it is called. Then is 1 is equal to 1? Yes, it is. So now they are returning 1 from that. Then you have to just put it into this, and after that you can getting the answer, which is equal to 120 here. So that's how the whole code is working. So this is the flow of the problem. For understanding this code, again you have to try it on your copy, so that you can get all those stuffs. So let's move forward for another problem if we have. So before learning, basically you have to understand some properties. So someone can ask in interview why we should use recursion. We have another approach to solve a problem. So this simplifies the code, like just like a traversal tree. When I will be dealing with binary search or binary trees, then I will explain it to you how to traverse a tree using recursion. It has been used in multiple concepts of backtracking. When you solve a problem of merge sort, the next lecture will be of merge sort. So in merge sort I will explain it to you why recursion is so helpful, because through recursion you can make this very basically difficult code into very simple steps, so that's everyone can understand. So if this is your first time watching a video on recursion, then it might take you like it is a very difficult topic to understand, but not, this is not a true case, because when you just solve for a small case, then you have to just call the function. You don't have to do anything. You have to just see a big problem, make the problem into very small sub problems, and you have to just solve a single problem, and just what you have to just calling that function. So that's how the whole process of recursion is being working. So what are the disadvantages? So basically it can lead to high memory uses due to stack call. So in every process of your function call, there is a creation of stack, basically functions in stack. So that's how it is taking more memory as compared to uh, what iterative methods or different approaches. So risk of stack overflow. So if the memory of the stack is full, then we will call that this is stack overflow. When I will explain the stack data structure, then I will explain how basically stack underflows and overflows working and how do you use it. Okay, so when to use recursion? So when a problem can be divided into smaller subproblems. So you can't use recursion everywhere. When you see that this is a big problem and this big problem has build on small problems, and if I solve this small problem, then I solved all the problems. So that's how this recursion is working. So let's move forward, and I have solved this problem, and I have basically what I have done. So I have created an int type of function, and if n is equal to 0 or 1, you can return 1, and this is how the whole code is working. So this is direct, they are returning this thing. I have created a answer variable and then I return that answer. So both are almost same things. So these are some simple problems on recursion. So let's move forward on another problem, which is this: what is Fibonacci series? So what it is? So when you Google that what is Fibonacci series, then someone will say that 0, 1, 1, then 2, then 3, then 5, then 8. You have to just see what is the pattern, then 13, and then so on. So that's how this whole code is working. Like, you have to just add these first two letters and get this third number. When you add 0 plus 1, then answer will be 1. When 1 plus 1 added, you got 2. When 2 or 1 added, answer is 3. When 2 or 3 is added, then answer is 5. Then 5 and 8 when you added, you got 13. So that's how the Fibonacci series is being designed. So let's execute, and you have to just first break this big problem into small sub problems. So how you can solve it, let's see. So let's make a function for that. I'm commenting all those stuffs. So I'm creating a int variable for taking input from user. Okay, and the name of the function is, let's say, Fibo. Okay, and I'm passing a n variable. Okay, and I'm creating a int type of function which will be returning something. So int n is the number which we are passing into the function. Okay, so what is the base case? You have to first write it out, base case, and just calling the recursion. In every problem you just see this recursion or processing also. These are the three main steps that are involved in a recursion. This is an optional step, the third one, but these are two mandatory basically code that you have to write while solving any problem of recursion. Got it? So you have to basically make a base case for that reason. So before, what is the base case? You can just analyze from watching this and this only. You can easily find it out what is the base case. So we know that we can find the third number or the any number. How? Just adding the previous two numbers. So as we know that this should be the reason that n plus 1 plus n plus 2 will be the nth number. Okay, so but we don't know the first two letters. So if we make something like that, if n is equal to 0, if the user asks that if what is the zeroth index of the number, just return 0. Why? Because it is quite visible that the first number is 0. If n is equal to 0, then you have to just pass this number. And if user is asking, because if it is basically increasing with 0, then that's how I'm doing all those stuff. And if n is equal to 1, then you have to just return 1. To make all those code very simple, you can do also that this kind of thing you can understand, like if n is less than equal to 1, just return n. Same thing I have written, but I have elaborated in very simple ways, so each one of you can easily understand. Okay, I'm creating an answer variable to storing how we can basically find it out. So let's just calling the function. What function? This function, Fibo. Okay, Fibo. I'm just calling n minus 1 and then just Fibo n minus 2. That's how the whole code is working, and just return the answer. Nothing. So what I have done here is I have created a base case and just calling the recursion. How? You can do also these things, that you have to just remove all those stuffs and just return. The same thing will be working absolutely fine. So let's execute this code and just printing. So if you want to print for, let's say n is equal to, let's say 1, 2, 3. So let's say for n is equal to, let's say 1. So if you give n is equal to 1, then answer is 1. If you give n is equal to 0, then it will be printing 0. If you printing, let's say n is equal to what, let's say 3, then answer should be 2. How? Because 1 plus 1 is equal to 2. And if you give some input, like, because I'm starting this series from 0, not from 1, so that's how, if I'm giving input 0, then answer is 0. Okay, and if you give like 0, 1, 2, 3, 4, 5, 6, if you give input 6, then answer should be equals to what, 8. So let's see, is it working or not? Perfectly fine. So I will explain this code again so that everyone of you can understand what I have done. I have created an int variable and I'm taking input from user, and I've created a function Fibo, and this function will basically create a Fibonacci series for me. Okay, so I have to make a int type of function which will be returning something. So what it will be returning an integer value. Okay, I have created or solved a small problem of a big problem. So just I have solved this thing, like if n is equal to 0, if you are giving n's value is equal to 0, then we have to return 0. Or if you give n is equal to 1, then the answer should be equals to returning 1. It will be returning 1. Okay, and I have to solve for a generic. So that's how the whole code is working. So I have to just making what I'm just making a big problem into smaller parts using this base case, and then just calling the function of recursion. That's it. I'm not doing anything else in this code. That's how the whole code is working. So let's move forward if we have another problem. So yes, we have, what we have to do is sum of n natural numbers. Okay, so I have to create all those stuffs from 0. Okay, so what is the problem? First I have to explain to you. Let's say n is equal to n, sorry, not n is equal to n, it is int n, and sum up to n. Okay, so that's the name of the function, and I'm building this function, and the function should be, let's say, int type of function I'm creating. Okay, so how to basically do all those stuffs? So basically, if someone will ask you like you have to just print for 5. If someone will give you this number, what you have to do, just 1 plus 2 plus 3 plus 4 and just for 5. You have to do just thing, and the answer will be 15, as we all know. So this is how the whole code is working. So you have to basically, if you solve this big problem, then you have to do one thing, is that you have to solve one of the smallest problem that could be your base case, and after that just you have to call the recursion. That's it. This is your task. Okay, so for that reason, let's say if someone will not give you anything, let's say n is equal to 0, you don't add a number. So this is your, this case should be your base case. What is the base case here? The base case is there that n is equal to 0. If n is equal to 0 means you don't have to add something, that there is no number. So if this is the case, then you have to just return what? 0. You don't have to do anything. So this is your base case. So that's how the whole code is working, and then you have to just return what? You have to solve for n and just sum up to n and just call for n minus 1. That's how the whole code is working perfectly fine. And just you have to see out all those stuffs and just giving an input of, let's say, 5, then it will be printing 15. So that's how the whole code is working. I will explain it to you what exactly what this code is working, so that's so everyone can understand. I have solved this problem in 2 steps. First step, I have created a base case, okay, and in this base case I have solved the smallest possible sub problem of the big problem. So if the n is equal to 0 means you don't have to add a number. So if you have nothing to add, then your answer is equal to 0. If you have zeros and the value of n is equal to 0, then you have to solve nothing, so answer is 0. And if, let's say, 5, then you have to just 5 plus the same function call. What it is? 5 plus sum up to 4. Why? 5 minus 1 is equal to 4. Then the same problem is basically the same function is calling. Why? Because in recursion, in every problem, the function is calling itself. So that's how the whole code is being working. You have to just dry run on your copy and just see how the flow of code is working. So I think I'm able to explain to you how the whole code is working. Then your task is to just dry run this problem so that you can easily understand what is exactly going on. Let's move forward if you have another problem. Okay, some good problems of recursion, which is reverse a string using recursion. Okay, so what is the problem? So let's see string name. Let's say, okay, you're taking the name as a string and just make a function which is reverse, reversed reversed string, and just passing. So you can't solve this problem if you haven't solved the problem using 2-pointer approach. I'm just telling that to solve this reversed string problem, you have to first understand how we can reverse a string using 2-pointer approach. That I have made a video on string. So in string manipulation, I have explained it how the whole code is working. If you are not seeing that thing, then you have to watch it. Then you can come on this lecture and then you easily get how I'm doing all those steps. So in that problem, we have 3 things. What was that? Start variable, which was pointing to 0, and end variable, which was pointing to the last index of the string. Okay, so I'm passing all those stuffs. Start, 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 and then just end. Okay, so I'm just creating this thing. Okay, let's say I'm creating a void type of function. Okay, so string name and then int start and then int end. Okay, so what was the base case at that time? So if you notice that if start is greater than equal to end, because while loop was basically running when start is less than equal to end. So when while loop was not working, so it was not working for start is greater than equal to end. So that's how the whole code is working. Then you have to just return, that's it. You have to just return it from the function. Okay, and then what you have to do is just checking or just for reversing what we are doing. what is the processing steps. Why I have called this problem advanced, because in mainly in these 2 or 3 problem we don't have the processing block. We have just 2 blocks. The first is base block and another is recursion call. So here we have 3 blocks: recursion, processing, and then recursion call also, recursive call also. So what was the processing? You have to just swap it. What swapping? Swap what? The name of start to name of end. Okay, that's it. And just you have to call the recursion. How you can call? Return, reverse this thing, copy just and paste it over, name. But now how start was moving forward direction, so how you can write it like that, and how end was moving to left side, so how end -1. So if you are not getting it why I'm using all those stuff like start +1 or end -1, you have to watch that lecture of string which is in this playlist. You can easily watch it and just see. Let's execute this code and let's say this code is working or not. After that, for that reason you have to pass this string to in this type. You have to just pass actual string. You don't have to make a copy, so that when I am printing this string, then directly reversed string is printing. So I am printing before reverse, just print it out. After that, after reverse, because I'm passing actual string, not a copy of the string, so that's how I'm using that thing. So let's say I'm passing Ayush. So after reverse, this is perfectly fine. So I'm explaining this code again so that everyone of you can understand why I'm doing all those stuffs. So basically I've created a string variable for storing a string value, which is a combination of characters. So I'm taking input, okay, and I've created a start pointer which is pointing to the first element or the 0th index of the string, and I've created a end variable which is pointing to the last element of the string. Okay, so what I'm doing, I'm just printing this thing before reverse. So as we all know that this will be working fine for any number, any name. Okay, so after that I'm creating a function which is reversed string. So for any problem in recursion, you have to do 3 things, 3 steps. First step is this condition, which is called what? Base case. Okay, so what is base case? So base case is the smallest problem that you have to solve. So how this is working? So you have to dry run on a paper and copy. So that's how you can understand why the start is greater than equal to end, and then you have to return it. So it is very clear that if a start is greater than end, so what is the significance of start? If a start is the greater as compared to end, so you can just see that thing, but you have to just dry run on your copy and pen. So how all the function, how this base case is working, and just you have to do something. What you have to do, you have to swap. We were swapping in the iteration in this in that approach of 2-pointer. We are also doing the same thing. That's why we are doing this thing, and we are just calling the function again. So that's how the whole code is working. So let's move forward if we have another problem to solve. So yes, we have another problem, and the name of the function is check palindrome. Okay, so let's explain this problem, and then I have to solve this problem. Let's say the problem name is, you have to just check the number is even palindrome or not. So let's say I have created a string name and I'm taking from user, and I have to check whether the string is palindrome or not using recursion. Okay, so I have explained in previous video on string how to check whether the string is basically palindrome or not. So is palindrome. So this is the name of the function I'm passing. The string, also the start, also as well as end. So what are the starts? I have explained the same thing in the previous problem. Start is pointing to the first index of this string, and end is pointing to the last index of the string. Okay, so that's how the whole code is working. I have created a void function, so in this problem I'm also creating a void function, and string name is the name of the string, and start is the first pointer or the starting pointer, and end is the last pointer, which is pointing to the last index of this string. Okay, so what is the base case? You have to analyze what should be the base case. So the base case will absolutely same as in the previous problem. What was the base case? That if start is greater than equal to end, then you have to return nothing. You don't have to do anything, because you have traversed the whole string. Okay, and just you have to see whether if let's say the name of start is not equal to, let's say, what, name of end, then you have to just return what, for that reason. Okay, let's say if you don't create all those things and just create a boolean function, okay, because you have to return something here, so that's why I'm using all those things. If you do this, and if this is happening, I'm not creating a void. Let's execute with a fresh, let's say bool, and the name of the function is very simple, and I'm creating string name, and start is the first pointer and end is the last pointer. So basically, if you traverse the whole string, okay, if you traverse the whole string, and after traversal, basically what is my approach? My approach is very simple. The approach is that if I traverse the whole string, and if I found that everything is working perfectly fine, means the first element is equal to last element, and I am moving the start pointer to the next pointer and taking back the end pointer to this previous one, and everything is perfectly fine, then I just have to return true. Let's say for, let's say, the start is equal to end, and return true if I traverse the whole string. And if I create something like a case or some if condition, that is that if the name of start, I have created for another case, like if this is not equal, then I have to just return what? Return false. That's it. False, the spelling is wrong. Okay, and what I have to do? Just return this function is palindrome. That's it. This is my job. Name, and I have to give start +1 and -1. So that's how the whole code is working. So basically, if I printing this thing, and if it is giving 1, means the given input or the given string that you have given is palindrome, or if it is printing 0, means the given string that you have given it as an input is not a palindrome. So let's execute this code. So copy. Okay, so let's see. Yeah, it's perfectly working. So if the first is equal to the last, so it is, I have explained what is palindrome in previous lectures. So it will be giving output as 1. Is it giving perfectly? So let's say for Ayush, so it is not a palindroming, so this is giving 0, so it is perfectly fine. So let's explain this function again, so that everyone can understand. So I have created a string which is equal to the name of the string is name, sorry, and I'm taking input from user. I have created 2 different variables for storing 2 pointers, which is the start pointer is pointing to the 0th index of the string, and the end is pointing to the last index of this string. And I have created a palindrome function, and I'm passing name, the start pointer, as well as the end pointer. So that's how the whole code is working. So this is our base case. What is base case? Base case is very simple to understand, which is you have to solve for smallest possible case. You don't have to solve base case. This is not base call, it is base case. This is base case. Okay, so if start is greater than equal to end, then you have to just return true. How I have explained in very detail in this lecture, and in the same problem I'm doing the same thing. If you're not getting it why it is doing, then you should first understand how to checking palindromic condition using iteration method that I have solved in string lecture series. Okay, so this is very famous question. Then you have to just check it. I have created a different case where the start is not equal to end. The name of start is not equal to let's end, like in the case of Ayush, because A is not equal to H, so just return false and just move. And for each case you have to just traverse it, and after the whole traversal of the string, if I am not getting in 47 to 49 line of code, then the answer should be equals to true. How? Just you have to dry run all those things so that you can easily understand. So that's how whole code is working. Let's see if you have another problem to solve. So tips for recursion. So what are the tips while solving any problem of recursion? Always define a clear base case. What is base case? The smallest possible problem that you can solve very easily is the base case, and this is the main thing that you have to basically analyze, because if you find the base case, the problem is 75% problem you have solved. Okay, so use recursion only when the problem can be divided into smaller subproblems. If you see that this can't be divided into smaller subproblems, some problems, then you don't have to use recursion. You have to use recursion only if when you can break the problem into small subproblems. Okay, so be cautious of stack overflow for large input. So basically you can't taking inputs which is very very large. So these are some drawbacks of recursion. So try converting recursion to iteration if possible to optimize the memory use cases. So if someone will ask in interviews, like if the given string is palindrome, or let's say reverse a string, or adds up to n numbers, or do Fibonacci or factorial, so you don't have to do this recursion. So why we are studying? Yeah, this is a great question if you ask. So why we are studying if we use this thing? When you will doing what trees, some sort of stack problem, some sort of queues problem, and many more concepts, then you find it that recursion can solve a very complex problem into very simple parts, because you have to just do one or two things. What it is, you have to just find the base case. If you find the base case, then the problem is 75% solved, and just you have to call the recursion the 25%, or if the problem is slightly complex, then you have to just process how the processing is done. So that's how all the things has been written over there. So we are concluding this lecture. So recursion is powerful tool for solving complex problem, because you have complex problem. I've explained all these things that you have to just go through all those stuffs. So mastering recursion requires practice, understanding of base case and recursive cases, as I've explained to you. Applying recursion wisely to balance simplicity and efficiency. So that's how. So thanks for watching this video. Keep practicing recursion, because recursion takes a lots of problem to master. So if you have any questions, so drop all the questions in the comment below. I'm happy to answer all those questions. So if you really like this video is quite helpful for you, then please like, share and subscribe, and thanks for watching this video. Goodbye.